Okay. Oh wow, there's people at the top as well. That's cool. So, hello everyone, and it's a great pleasure to be back at JSpring. I was here last year as well, and I got asked if I wanted to come back, and the answer was an overwhelming yes. I really enjoyed it last year, so I'm here this time with a different company actually. So I'm going to be talking about security vulnerabilities in Java, and really we're going to be. I mean, vulnerabilities are typically ecosystem agnostic, so it doesn't matter whether it's a vulnerability can exist in Java, or it can exist in Node, or it can exist in Python. So we're going to show you a few apps, two of which are going to be Java, one of which is going to be Node, but we're really going to focus on the vulnerabilities that can exist across them. So a little bit about, is this on? Okay. Whoa. A little bit about me. I help run the virtual jug with a whole bunch of other people, also the London jug, and I'm currently running the DevRel side of things at Snyk, which is a little startup company based in London and Tel Aviv, and they're entirely focused on security, which is one of the topics that we're going to be covering heavily today. I was actually in Bulgaria. I've got a tough week this week. I was in Bulgaria yesterday, I'm here today, and then I'm flying off to Stockholm tonight, all conferences, and unfortunately I got in a little bit late, so I missed the speaker dinner last night, unfortunately. But I got there for some drinks, and I was told, "Don't worry, we'll take you to this amazing Michelin star restaurant," and it was in the cloud as well. So the guys took me here to this cloud Michelin star restaurant. The menu was actually was pretty spectacular. Is this going to go? The menu was pretty good, very, very varied, lots of nice things. So we sat there having a lovely banquet outside. It was one of the best speaker dinners I could imagine. And then they obviously made me a NL Jug member, you see. So we're all good now. We're all official. I'm going to talk about DevSecOps. Who's heard of DevSecOps? A few people. Who's heard of DevOps? Who doesn't want to put their hand up? Right, so yeah, DevSecOps and DevOps, well, you've pretty much guessed it. They kind of put dev a little bit to the left, put ops a little bit to the right, and try to squeeze security in it and make it a cool phrase as well. It's just about adding security into an existing DevOps workflow, right? We kind of expect that. Now, security, when you think about security, you think about an audit that occurs maybe once a year, once every 2 years, or an audit maybe that you want to happen, but it just never happens. And this just isn't good enough with our existing workflows. So obviously our existing workflows are very, very feature-oriented. Okay, when we think about what we want to do, it's I want to be able to do this, and I want to be able to do it well. We don't think about maybe even performantly. We don't think about securely. We're too feature-oriented. And one of the things that we're doing more and more in terms of our delivery, our continuous integration, continuous delivery, is trying to reach the market as fast as we can from making changes. Who here pushes to production once a day or more? 1 hand, 2 hands, 3 hands, 4. Once a week? A lot of people. Once a month? Okay, the majority of people. Who does add security into that release? Every single release, who checks for security? Like 5, 6 people, 7, 8, 9. Okay, this is the problem, right? When we try and increase the cadence of when we push to production, we need to make sure all our tests get provided as well. And we need to push that into the development lifecycle. So, there is a lack of security focus, and the two things which really count is the organization's reputation's on the line, and also customer data is the thing that we're going to be leaking. Okay, when we breach the most sensitive information possible from our customers. And if we look at how bad the situation is, let's take a look at Maven. Almost 2/3 of reported vulnerabilities in Maven don't get fixed. Okay. This is very, very critical. And if we look at the big, I always hate this slide because it's, Equifax is used as an example so often in security. But we've all heard of what happened with Equifax, so I'm not going to focus on that. I'm going to focus on the actual breach and say, okay, when we realize that Equifax was breached, it was a Struts 2 vulnerability. And if we look at how attackers focused on Struts 2. This is just an attack timeline of Apache Struts 2 attacks. Nothing to do with Equifax. This is just what happened with Struts 2. When a vulnerability occurred here in mid-March, almost 2,500 attacks on Struts 2 around the web was happening because people realized there was a vulnerability in Struts 2, and when you have a single target, which is a package, an open source package, which many people use, attackers have a vast number of victims that they can possibly attack with just using a small amount. So I've talked about Java, but it's more fun to pick on JavaScript, just because. So let's take a look at NPM. So NPM has, this slide, I actually don't want to update this slide. This slide is actually about 6 months, a year old. And it says 400,000 packages, because I like saying today it's actually about 600,000 packages. So you can actually see the rate of increase, the number of packages that are available on NPM. 6 billion downloads per month. It's just huge. And over 70,000 people that are actually contributing to the NPM repository. Now, I don't know if you're going to, I'm going to show you your application now. I don't know if this is confidential, but this is your application. And this is your code. And this is probably fairly a reasonable assumption to make about a vast number of people in the room. Your code, the area of your actual code within your IDE that you're typing away is actually very, very small compared to the actual amount of your application that you're bringing in through open source libraries and vulnerabilities. Who uses Spring, for example? Wow, okay. Who uses Spring Data? Who uses Spring Data REST? So about 10, 15 people. Who's heard of Spring Break? A few people. Weirdly, the people that didn't put their hands up for using Spring Data REST, where it actually is vulnerable. Okay, I'll show you a vulnerability. I'm going to do a whole bunch of live coding as well, so we're not going to do just slides. But yeah, I'll show you a vulnerability there. So when I created my Spring my Spring application just to demo this Spring Break vulnerability, I counted the number of lines of code, and it was 80 lines of code and about 6 or 7 dependencies, okay? Which is fairly reasonable, you're using Spring. But what does that mean in terms of the transitive dependencies? Well, actually, who can guess? How many total dependencies, direct and transitive, do you think I had? 100, almost. I think it was about 68, 69, something like that. And lines of code, how many lines of code did my application have? Remember, the lines I typed was 80. Okay, and there was a lot of open bracket and closed brackets and things like that as well. So 80 lines of code. Any guesses? A couple of million? Wow, that's very pessimistic. No, optimistic, sorry. It was 690,000 lines of code, okay? And so now you can see, right, 690,000 lines of code on a really basic Spring app, and my code was 80 lines of code. Okay, so this is great, though, because think about it. For 80 lines of my code, I can use all this amazing code, and I can create my application with all the amazing features that Spring, the container, the framework provide me. So it's a great thing and a bad thing at the same time. Let's give you another example. Who uses serverless here? 1, 2 brave people. Who uses microservices? Who uses monoliths? Why is that funny? Monoliths are great. So here, this is my serverless example. 19 lines of code. All it does is just grab a file and throw it into Amazon's S3. Okay, not too interesting. It has 2 dependencies. How many indirect or transitive dependencies do you think this has? 50 million. Very close. 19 dependencies. How many lines of code do you think pull in from these 19 dependencies? Remember, I'm just using 19 lines of code. A couple of thousand, 200,000 almost, right? Again, just another example of how we're doing that. So let's look at some numbers. I mentioned this is actually a report that Snyk produced, very similar to some of the ones that I've done before. But this was actually before I joined. NPM, you can see the NPM growth there from 200 million packages downloaded per day up to 400, and like I say, that's kind of 600 now. If we actually look at the other ecosystems, so Maven here, almost a 30% increase year on year. This is from October 2016 to October 2017, so 1 year, and this is the 30% increase in the number of indexed packages, so number of packages available in Maven Central. What percentage of 430,000 sites that we looked at had least one front-end library with a known vulnerability? What do you think? 90? Any others? 100? I love the optimists here. 77, so 3/4 of sites, and not a small number of sites we tested. 3/4 run with at least one front-end library. See, I told you NPM was bad. Let me show you something which Java is going to beat Node on. Critical package vulnerabilities. So you can see here, up to 2017, the number of Java critical vulnerabilities has increased massively. Node increases as well, but if we look at this hockey stick of number of open source vulnerabilities per year, it's rising hugely. And I think there are two massive contributions to this. One of the contributors is just that open source is being more and more adopted these days. When I joined IBM, gosh, almost 20 years ago, IBM wasn't huge in open source. You look at it now, it's like ridiculous. It's open source all the way. Even Microsoft have adopted open source, right? Everyone is adopting open source. And also, attackers are focusing on open source because they realize, one attack vector has huge number of applications that use those libraries. So this is what's causing this. Now, maintainers do react very, very quickly when they know they have a vulnerability. Around 2 weeks when they actually fix their issues. The issues though remain hidden for around 2-3 years until they're actually found. So this is from unknown to being known. So this is 2.5 years a dormant vulnerability exists. When we look at open source maintainers. They don't really consider their know-how to be kind of that high. Who here would say they have a high know-how of security? Yeah, a few people. Interesting. Not even half state that their projects and repositories have had a security audit. And this is interesting, actually, because very often, whenever we are coding our own applications and our own projects, we always put high standards on our audits and maybe trying to do security as much as possible. But very often, developers will tend to just use a cool open source project because it does something cool and I want to pull it in and doesn't this look amazing? But we don't actually look at the security implications of that project. Now, obviously, Docker as a cool new technology isn't going to have that many vulnerabilities in their projects, right? How about the top 1,000 Docker containers? What percentage of them do you think have at least one vulnerability? 80? 76.6%. All right, so again, 3/4 of the Docker containers not being used, but made available, have known vulnerabilities, okay? And a lot of the time, yeah, you can fix them. There are upgrade paths. Sometimes there aren't fixes. There aren't upgrade paths. So sometimes there's reasons why they have known vulnerabilities. But yeah, it's still pretty big. So open source has exploded, and attackers are targeting open source software. So one vulnerability, many victims. I don't want to do too many slides, so let's have a play. Okay, so what should we start with? Let's jump to let's jump to Java first. Okay, where am I? Okay, perfect. So I'm going to jump over here, and I'm going to go to. Oh, you can see my email. That's nice. Wow, you could have been watching that for a long time. Okay. Let's go localhost 8080. Right, this is my MVC to-do list. So, in fact, first of all, I'll show you, yes, this. So if you go to the GitHub Snyk repository, there are a number of applications here. There's Snyk, there's Goof, and there's JavaGoof. Goof is the NPM version. JavaGoof is obviously the Java version using Spring and Struts. I think there's actually another one that I haven't pushed over, but I will do. This is the Spring Break version. That's currently on my personal repository. So these are all obviously open source. They have vulnerabilities, but it's kind of nicer to try and if you want to hack, it's easier to hack on this one than it is like real sites in real life because that's kind of a little bit illegal and rude. So yeah, if you wanted to play, we have all the code here, and we also have the exploits directory, which has all the scripts and commands that you need to run in order to get your exploits. Okay, so what I've done here, I've just so this is Snyk. It's actually free for open source and free for the majority of people as well. What I've done is I've integrated it in with my Google account. I've added my projects, and here I can get if I show my projects, I get full reports on all of my projects that I've got with high, medium, low vulnerabilities. So the one I'm going to show you first is going to be JavaGoof, which is this one. So I can click on the POM XML. Oops, not that one. Which one? This Struts POM XML. And here we have arbitrary code executions or remote code executions. This is pretty much the nasty one. This is the arbitrary code execution for Struts 2. So this was the vulnerability which was used for the Equifax hack, and it's pretty shocking actually how much kind of anyone Struts users here, Struts users, and I say it like a drug. Any Struts users? Yeah, this was it's amazing how many people are actually still on the lower versions of Struts that do have this still exposed. But we're going to expose it. So let's go and have a look at the actual application first. Whoops. Oh, I am here. Application here, to-do list. So let's sign up quick. My name, Simon. Email, Simon Snyk. Oh, come on. Oh, you already have it? Oh, wow. Sign in. Email, password. Okay, right, so this is my to-do list. Buy wife flowers, excellent, that's already there. 1970, still priority high, that's a shame. But I can, it's actually her birthday on Saturday, so I do need to do something like that. But I can create to-dos here, so I don't know, buy milk, due date, whatever, still 1970, priority medium, create. It's just this usual app. It's got an about. I can see we're using Struts 2 at version 2.3. This is a vulnerable version. We're using Spring at version 3.2 and Hibernate at version 4.3 because I make bad life choices. So we're going to exploit this now. We're in the JavaGoof directory, and I'm in the exploits directory. So the first thing I want to do is cat the Spring, where is it? Spring exploit headers. Okay, let me just show you that at the top. Okay, so the way the Struts exploit happened is it effectively sent a request with a certain payload in its header, which caused an error, caused an exception, and in the error path, it was actually the error path of the request which executed remote code. And this is the specific payload which you need to add in the header. One of the powerful things about this exploit is you can just make this request. There's nothing you need to set up. There's no kind of gotchas to it. You just send this request, and you can add a command here, which we're gonna substitute in a minute. You just add whatever command you want there, and that's gonna just locally run. So for example, if I cat the Struts exploit, which is let's grab this one. So I'm going to cat this Struts exploit, and I'm going to substitute the command for, in this case, env. Okay, and I send this across HTTP to localhost. I run that, and I get my environment variables. Okay, so it's grabbed my environment variables from this machine and sent it out to me. So what do we have in our environment variables? We have things like database users, database passwords, that kind of thing, right? And yeah, we can just grab that straight away. The other one, what was it? It was the password one, right? Let's grab the passwords as well. This one here. So this is effectively gonna cat the etc passwords and push that back. There's not a huge amount of really interesting information here necessarily, but we can look at which users are on the system. We can then try and break into that. What's more likely is if I wanted to come in here, I might want to, instead of catting that password, what I might want to do is just actually browse the file system, for example. So I can, literally do something like ls-l, and I can actually now browse the file system. I can start traversing the file system. I might go something like, do a find dot, and all of a sudden I can actually see everything that's going to be in my application. right? So now I can traverse the file system. I can actually see what's installed. I can maybe cat some config files. I can maybe add some config files, update some config files. I can add some JavaScript into this application, which is going to be running, which is going to serve it, and all of a sudden all users are going to find some nasty JavaScript. What else can I do? Well, if I wanted to see what's running, perhaps I can just have a look at some processes. So I can ps -ef, and bang, I can see all the processes that are going to be running on this machine. So you can start, and with the Equifax break, it's not something that happens very, very quickly. It's not like a smash and grab where you just break in, it's like, haha, grab all my data from my database and run. It actually lasts a long time. It can last weeks, or I think Struts happened across a month, or maybe 2 months even. And what happened with that one is they were looking, they were gathering information, gathering knowledge about the file system, about what's running, trying to find other ways to break in once they're in. And then once they have their breach, it actually took like a month or two before Equifax even knew they were breached. So yeah, that's the Struts vulnerability. I'm also going to show you the Spring vulnerability as well. Actually, I think I have this. Let's see if I'm still connected. Let's see if that will work. Yes, it does. Okay, so let me find my Spring. Is it this? No, it's this. Okay, so this is my Spring application. No, not that. This is my Spring application here. So it's just a Spring Boot application. This Spring Boot application is like a grocery list, so you can add elements to it. If I show you the domain object here, this domain object just has a name and a cost. So I can put something in like milk and provide a cost, and this is going to add things to my grocery list. The key parts here is that we have an item repository, which extends a CRUD repository. So people who use Spring Data will already know what all of this is. This is effectively going to provide me. I can just add nice interface methods here. And a lot of the time, it will automatically be backed by some nice Spring implementation code, which is going to perform all of the finds for me. I extend the CRUD repository so I can actually run some nice CRUD methods on that. This is the interesting one here. This is the annotation, the repository REST resource. This is the annotation which is going to add Spring Data REST, which allows me to access these endpoints through REST. And I can show you that running here. Oh, before I do that, I'll just show you a little bit of initialization. I'm going to add a whole bunch of stuff here, beans, milk, bread at different costs. So if I come here, I can see if I go here and just put /items, I can get a whole bunch from my response body. Some nicely formed JSON. It's just a REST endpoint. Nicely formed JSON showing here I've got beans at 0.5. I've got milk at £1.09. Obviously Brexit hasn't happened yet, so these costs are going to go up probably quite sharply. If I do item/1, obviously this is just straightforward REST. But the Spring break occurs when we try and add some Spring expression language in here, which is a nice little way of doing more complex kind of searching. And using, if I come back here, I'm going to come out of here and go into my Spring goof, into my exploits. In the exploit JSON, this is the key bit. Again, just a payload which we're gonna be adding, and this is another one like Struts 2, whereby we just send a request with a payload, and that payload is pretty much the same, and we can pass in. I think here we get the runtime, right? Yeah, we get the runtime, we get an input stream, and then send that back to us. In this case, we can just run any command we want. If I cat the Spring exploit env, for example. This is actually just going to be, where is it? There. It's just going to be running env, getting the input stream and sending that back to us. And it's calling this RESTful endpoint here. So if I was to run that, run Spring env like this, it's been fixed. Oh, I know why. This is the to-do list. I'm sending it to the wrong. Let me cat this. I'll copy this, and what I'm going to do is I'm going to send it here to my. So this is this application's actually running on Cloud Foundry right now somewhere in the world. So if I run it on Cloud Foundry, There we go. This is now the environment variable, all environment variables from Cloud Foundry. Okay. Very similarly, I can do exactly the same with my passwords. Where are we? Here. So I can grab that, delete this, point it to Spring Break, and this is now the etc. password on that Cloud Foundry instance. So it's a little bit more believable when it's a different machine, right, rather than my laptop. But yeah, the same thing would happen. And of course, at this point, I can run whatever commands I would like. So this is Spring Break, which is in Spring Data. Again, the powerful point of this is there's nothing I really need to do other than hit an endpoint and add a specific payload. Okay, so if you are using Spring Data and you're exposing your endpoints, your domain objects through Spring Data REST, and you're at a specific version, then you are exploitable with this. To understand what the specific versions are, you can go to a database like the Snyk database or the CVE database or whichever database you want to look through. If I was to actually look at that now, Spring Goof, which one is it? I think it's this one. On Spring Goof, you just find the arbitrary code execution on the Spring Data REST Web MVC, and the remediation is the fact that your dependencies are out of date, and it will tell you which dependencies you need to go to in order to move to the version with the fix. Okay, you can do that manually, or you can use tools like this. Okay, so that's some in Java. I'm also going to show you another application. This is actually running locally. Whoa, look at that. I was doing this yesterday at JPrime by the look of it. Right. So this is my amazing web app. It's pretty special. It's a goof to do app, so I can type things in. Hello, bye, flowers. I can use markup as well, so I can go buy beer for really important things and make it bold like this. And yeah, I've also got an about page, which is pretty well. It's okay, this app, but I wouldn't call it that. And that's just serving from the public. And if I was to go back through here and actually have a look at what was vulnerable here, I'll go to my goof, and we can see there's going to be quite a lot vulnerable here. So the first thing I'm going to show you is a specific directory traversal here on the vulnerable module ST, which is basically a module that serves up content from a directory. Who's heard of a directory traversal issue? Quite a few people. For those who haven't, a directory traversal is where you as an attacker would try and break out of a directory that you should be in. Okay, so if you're potentially, well, let me ask you a question now. How are we going to break out of this application? With what I've shown you, how are we going to break out of this application or this directory? Any thoughts? It's a tricky one because from that point of view, we're not really getting access to the file system. It's kind of abstracted from us. Anywhere else? Use file? No, not in this case. I've shown you this. Any ideas from here? Change the URL here. Okay. We're not going to do it. We're not going to do it because we're going to try and pretend we are hackers, and hackers don't do things at a URL. So I'm gonna use an alias here. So I'm gonna type st1. So let's at least try and be the real deal. Okay, so I'm gonna curl that, and I get this back. So what do I need to do here then? // like this. Okay, what we actually do is we get back to the home page. We do that because we are using real-life libraries here. And these real-life libraries, this isn't a presentation where we just create an app that we know how to exploit. These are actual libraries, and they've thought about how people are gonna actually attack it, right? So they've found .. and they say, no, if you type .. we're not going to let you in because that's a directory traversal, and they know that. So how else can we do this? Encode it. Encode. Encode dot dot slash. What's the encoding for a dot? %2e. Put your hand up, who said that? You're the first person in the last 3 months when I've been giving this presentation that knew that. I'm really impressed. Are you a professional hacker? So there we go, %2e. So they've tested against the dot dot slash, but they haven't. So they're literally testing against the character dot rather than a URL encoding of %2e. I can just now do that a few more times, perhaps. And we get to our root. And what happens if you cd dot dot in a root? You get to the root. Okay, so you can just cd dot dot as many times as you want to know you can get to the root, and then from the root we can curl whatever we want. There's my accept a password again. And at this point, you can have a look around the file system. You can see what's installed. You can see what tools are being used. You can look at the config. You can see, what usernames are being used. Perhaps find, oh look, this default username password here. Let's try and attack that. Okay, it's all about gaining knowledge and understanding what is in use in the file system. Let's hack again. Next one we're going to do is the cross-site scripting. This is an interesting one, though. If I go back here, is it? Yeah, so let's do, what is this on? This is on marked. Cross-site scripting in marked. Okay, everyone knows what cross-site scripting is, trying to inject scripts into a website. This is actually through a marked, This is actually through a marked library, and this marked library allows us to do markdown. So, for example, the ** beer ** markdown for adding bold. So, how are we going to attack this with cross-site scripting? Say that again? Yeah, so JavaScript being something like this. Something like that. Thank you. Boom. Doesn't like it, and it's actually validating it. Not by default, interestingly. If I was to come here and if I was to cat the // what is it? Is it in? I think it might be an app.js. Yes, we've had to add this. Okay, so we're actually not making it easy for ourselves. By default, marked isn't actually sanitized for some reason. So we've added this sanitize function to actually make it sanitize our inputs. So yeah, unfortunately that won't work. Any other ways we can get a piece of JavaScript into it rather than adding HTML? If we think about maybe how we can add links. Say again? The beer? The import? No, not quite on the import. It would still have the same problem. Oh, okay. What, in a link? So if I was to do something like this. Let me do a. First of all, show you a nice. What is it? jspring.io. Oh no, NL, isn't it? So that's a nice JSpring link. If I was to click on that, I probably go somewhere, maybe. Yeah, JSpring. So let's actually do that again. At this time, we're going to add this as some JavaScript you want. Like this. So that will be JavaScript like this. Do you think that's going to work? Oh, it's sanitized it as well. It's there, but it's sanitizing it when we actually run that. It doesn't want to show us the link because it knows there's JavaScript in there. I can tell you though, and it doesn't like this, and it doesn't like this. Encode it. Right, smart ass. Where's that guy? URL encoding for a colon and a closed bracket. 2.9. Well, this actually needs it like this. What is it? Ampersand hash This is actually I've written it down. I don't know. I've got more important things to keep in mind. There we go. 58. Close bracket is 41. Okay, so if I run that, who thinks that's going to work? Hands up if you think that's going to work. And a nervous laugh of someone who really thinks there's something else going on here. I run that. Damn it, I don't even get a closed bracket. It is still there, but it doesn't like it, okay? Because it still knows. It still knows I'm trying to provide a colon and a closed bracket. I'll give you this one, because this one's actually tricky. What this is one where we can't necessarily break it because of the markdown, because of the library, because the library is sanitizing it well. But what we can do is make use of stupid browsers. Okay. Now browsers are very good because they sometimes say, "Oh, I know what you mean. You mean this," right? And it's quite nice sometimes because it actually creates a nicer experience for the user, unless it's past sanitization of the library, and then the browser goes, "I know what you mean. You want a colon here," right? So this is valid because it has a semicolon at the end, right? But if I type this, oops, if I go here and I type this correctly here, this is correct, but this doesn't actually have a semicolon after it. So this is going to pass sanitization function. Okay, but when the browser sees this, the browser's going to go, "I think you're missing a semicolon here, and what you really want is a colon. I'm going to provide that for you," and it does that. Okay, so now when I click on this, I get my alert, right? And of course, this is now going to be available to anyone who clicks on this. Anyone who goes to this website, and all of a sudden I can grab some session data, I can ping my evil server with a URL with some base64 encoded on their session ID or whatever, and then start doing some fun stuff. So yeah, there's an interesting one. Do you want another one? The vulnerability. Well, it's a tricky one, right? Where is the vulnerability? Where does the vulnerability exist? It's not in the library, because the library is doing exactly what it's supposed to do. But the vulnerability is in the browser. Well, the browser needs to update to make sure that no, there's no way. It's beyond the application. It's entirely outside of the application at this point. Well, what you could do actually. What you could do is the application could say, if you are almost trying to do this and you're adding JavaScript, then actually remove that entirely, so that by the time it gets to the browser, it doesn't quite do that. But yeah, that's an interesting one, because you don't expect any library developer to try and code against that, right? So there again. Yeah. Yeah. Fair point. So let's do another one. Who uses regular expressions? Keep your hand up if you like regular expressions. Keep your hand up if you like reading other people's regular expressions. One person. Right. Now, regular expressions are fun. If I was to write a regular expression like this, and this regular expression would match AAA, right? But you don't know how it's going to match AAA. It might try and match it just here by saying the A+, that's going to match as 3 A's on the A+. It might try and match it as 1 A from the A+, but then because of the star, it's going to do that 3 times. Okay? There are a number of ways you can actually match patterns, obviously. Now, when we look at regular expressions, the pattern matching, it actually tries to, it's very arrogant. It tries to find it. It looks through every single combination. Okay, so it uses a backtracking algorithm whereby if it gets to the end and it can't quite do it, it goes back and tries to update until it can find a solution. And this is great because you obviously, if a solution's there, you want it to find it. But it doesn't really work very nicely with the case where you've got a long regular expression and there is no match, because it takes a long time to get through that. So I'm going to show you. If I go for, what is this? It's in the MS library. This one here, regular expression denial of service in the vulnerable module of MS. There are obviously remediations to virtually all of these, just to upgrade. And this MS library, what I'm going to do is I'm going to go back here. If I was to say something like, now let's go over here. If I was to say something like type MS2, buy milk in however long. Actually, let's do that. Okay, that's fine. Buy milk in 60,000 minutes. Okay, that actually resolved pretty quickly. If I was to come back to my runtime and just hit refresh, buy milk in infinity days, nice. Because 60,000 plus a minute is a long time, but it matched it very, very quickly, and it's because it didn't need to go very far to match it, because it could match straight away. But what if after 60,000 fives and minutes we change minutes and be a little bit nasty and just put minita? Okay, what it's going to do is it's going to go through all those 60,000 fives, go through minutes, but by the time it gets to 8, it goes, oh bollocks, I can't match. Let me go back, and it's going to backtrack through 60,000 fives all the way until it goes, you know what, I give up. There is no match here. Okay, so if I was to run this now, we hang. How long do we hang for? Well, if I was to type hello here, it's hanging. It's hanging the thread until there. Damn, I will get that timing. Now, this is great if you're using serverless, because let's say you're using lambdas, and I ran this expression again and again and again. Oh, your lambda is going to grow, you're going to have loads of instances, and Amazon is going to make a lot of money. If you're doing something which doesn't expand quite as fast as that, then obviously you're going to get a regular expression denial of service, because all your servers are going to be hung, and no one can get access to your server. So this is a redos. How much time do I have? Am I pretty much out of time? 5 minutes. Okay. Yeah. Okay. I'll go back to slides. So there's some nice hacking. A couple of things that I want to add. Let me find some slides. Okay, this is an interesting one. Security considerations. So when we think about designing and developing against security, we need to think about prevention, and this is the one that we mostly think about, but we also need to think about detection. Okay, Struts and Equifax took over a month before they even knew they were breached, right? And this is important. How do we detect that we have been breached? Logs. Look at your logs. Look for absence of logs. Attackers, good attackers, are very good at backtracking. Are very good at covering their tracks. In fact, many of them will actually alter the ls file or the ps files, so that when you actually run an ls on a directory, you actually can't see directories that they are installing software and malware on. Right? PS. Yeah. If they're running processes, you type PS, you're not going to see them, because they're hiding those. They're hiding those from you. Response and recovery, how do you react? This is very much like a kind of communication thing and a process thing through your company. How do you react when something happens? And recovery, right? Do you have an environment that is good enough and a backup that is good enough that when you destroy your environment, you can bring it up again from source, so that there is nothing available on the file system that an attacker has already put there. Okay, so those are some important things. One of the interesting things here is Attack Trees by, I think it's Bruce Schneier book. And the example he gave there was about cracking a safe. And the whole thought process here is about, when you think about attack trees, how do you're trying to work out how attackers can get in. So work out, first of all, what they want from your application. You can get people to do this, you can get consultants, or you can do it yourself. What do they want from my application? Well, in this case, they want to open my safe. How can they do that? They can pick the lock, they can learn the combination, they can cut it open. How can they learn the combination? Maybe they're going to find it written down, or get the combination from the target, the person who knows it. How can they get it from the target? They can blackmail them, they can threaten them, they can bribe them. This is where software engineering gets a little bit more exciting, Now we look at this and say, okay, where's the risk here? What is the easiest way of an attacker doing this? Well, of course, some dumbass is going to write the combination down on a Post-it note, stick it on their monitor, and guess what? We can read that. the passwords that are written on the whiteboards, and then someone's doing a Google Hangout in front of it, right? This is the easiest ways that we can find this kind of information. So when you work out where people are likely going to attack you from, that's when you can say, now, this is where we can put our information. In the UK, we're getting some nice weather here, not as nice as where we are, but in the UK, we're not used to weird weather, like ±2 from around 15 degrees. So what we do is we open all our windows when it gets slightly hot, so that obviously the whole place doesn't feel like a sauna. And then on the way out, we shut the door, we lock it 3 times, and we make sure there's no chance of getting into that door, despite the fact that there are windows wide open. Okay, and you think, yeah, I'm really focused and secure on here, but nothing else is secure. And an attacker's going to come in, they're going to go, oh, do I attack this door with 3 different locks and alarms and everything, or do I just climb through this nice open window? Right. So it's thinking about where attacks are going to come from. Also, when we look at application architecture, you can think about where you need to specifically add security. For example, if you're using monoliths versus microservices, your surface area of attack on a microservice is going to be, more microservices are going to be much greater. Because when you think about having lots of perimeters for lots of services, potentially using different stacks, you're going to have loads of different potential libraries that there might be vulnerabilities in, and there's a much greater attack surface. But you have many different perimeters, whereas on a monolith, you tend to have 1 or 2 big perimeters. Okay, the advantage of the monolith is you're typically using the same stack. It's easier to secure, and you have kind of a smaller surface area of attack. But if someone does get into your monolith, then they have access to a much wider range of things. If someone breaks into a microservice, what's in that service? What damage can they do in that microservice? Okay. Also with serverless, a lot of the infrastructure is already placed for you, so it's kind of hardened from the infrastructure point of view. You're using up to all the latest versions and things like that. So the security problem then comes into your application, and that's where people are going to target. If you're using microservices, are you using HTTPS between the microservices? Because if you're not using HTTPS between the microservices and someone can break into the wider perimeter, all of a sudden you're then vulnerable to man-in-the-middle attacks, okay? Where someone can sit there, they can sniff traffic between your microservices, they can potentially augment the messages that are going through, and, sending wrong things, getting information, just sniffing data and sending it back out, okay? So there's different things that we need to think about, different security considerations for each. How do we then go about fixing these kind of things? Well, I mean, I mentioned Snyk. There are a whole bunch of other kind of tools like this. This one is free for open source, free for applications, as long as you stay within 200 tests every month. So I can show you how this would do it. What we would do is, if we was to go to let's go back to my projects. If I was to click on this, let's do this one because it has 11. This goof one. What we can do is we have all the vulnerabilities here. What I can do is I can click Open a Fix PR and Wi-Fi permitting. What that's going to do is it's going to say, okay, these are all your vulnerabilities. We can issue you with fixes. We can issue you with partial fixes. Some might not have fixes, but I can open a PR for that. And that's going to send a PR directly to your GitHub account, which is going to provide you with all the updates and different versions. And if I click on Files Change there, you can see it's updating the version numbers. Sometimes it will also patch, so if you don't want to jump to a big version number, there might be breaking changes, you can actually backport that patch, and this is all done automatically for you, and that patch will be sent and overlaid across your frameworks. So the nice thing is, it's done in your development workflow, and that's the key part. Okay, from a development workflow point of view, you need to be testing for known vulnerabilities when you develop, during CI, and use a tool like Snyk or something else, so that when you constantly build and constantly run, if there are known vulnerabilities, perhaps you want to set a threshold to high vulnerabilities only. If there is a high vulnerability or a medium vulnerability, you break the build. Okay. Then when you deploy, you can use tools like this to actually monitor your deployment, have and email you or send you an automatic PR when a new known vulnerability affects a version that you're deployed in. Okay. So try and do something like kind of security checking. At the very least, just look through. We have our database as well, which is completely free and open source. If I was to go to snyk.io/vuln. We have all vulnerabilities here. This is taking all vulnerabilities from CVE database, NVD database, a whole bunch of other universities, and we add information in here which allows you to remediate and to also understand what the vulnerability is. So I'm out of time. Thank you very much. I appreciate there was a lot of slides in there, but I hope you also enjoyed the live hacking. And thank you very much. I appreciate it.